get it.
Okay, let's sort that. So hopefully this.
I got that one.
Right. Fractions. Tell me, what do we do with fractions? First step is.
Simplify. Rationalize.
Well, there's one thing to note. When we rationalise a denominator, that means we have what in the question?
Surds.
Surd. We have no surds. We don't need to rationalise a denominator. I saw someone write that in the resit test. Part of their notes for solving something said rationalise the denominator. You know that rational and irrational refers to the surd. Yeah? Root 2. I was trying to be, subtle about it, but root 2 is an irrational number. So we have rational things here. We don't have anything that would be irrational. But fractions, we normally say let's work with the same denominators. Makes life easier. There is another thing. I mean, we could, for instance, this first one, treat it like divide by 7, divide by 12, and treat it as operations in that way. So I could times 3 by 7, times 2 by 12. But I think the way that we've been doing it so far is to make the denominators the same, yeah? So what do we choose? Yeah?
Lowest common multiple.
Lowest common multiple. Okay, which is?
84. Yeah.
84. So you've multiplied this one by 12 and this one by 7, so that makes 84. Right, so then I have to multiply the top as well. Have to multiply the top by 7. Right, so then we get 12 times 5x's.
Oh, I have that. 60x minus 12.
Okay, and the other side would be?
49x plus 21.
49x plus 21. Okay. Now, I just want to go through the... Oh, actually, yeah, I noticed that. I almost missed the x out. Do you know what? Something else I've just been marking as well. Someone missed out the x. And you might think, oh, it doesn't matter, I knew the x was there. But then in their next line, they treated it like a number without an x. So they added it, so they even forgot what it should have been themselves. And it was like, I would then add the 49 and 21, okay, and get 70 rather than having an x. So it does matter, even if you think you have noticed it. Right, so what's the deal here? What can we do at this stage? Yes?
Remove the denominator.
Why?
Because it's the same as having like a 1 under both.
Okay, so because there's two ways again to think of this. Because the denominator is the same, the numerators must be the same. So we can actually logically just write that 60x minus 12 has to equal 49x plus 21. There is another way to think of it though, which is if I were to multiply this whole thing by 84, that would get rid of the divide by 84. But if I do it to one side,
you do it to the other.
I have to do the same to the other, which gets rid of it there as well. So there's two ways to think about it. Either there's the logical approach, denominators are the same, numerators have to be the same, or the more operational approach, whatever makes more sense to you. Okay, but what do we do now?
Solve.
Okay.
So you remove inverse the 12.
So I'm going to add 12.
So it's 33.
So 60x is 49x plus 33.
And then subtract 49x.
Subtract 49x.
And you get like 11x. And then it equals 33. So then you do x equals 33 over 11. Also noticed.
I did mine a different way.
Did you? What was the different? Where did you change from what we did?
No, that instead.
Sorry, some of you are being very rude because Ali's just talking to you and you've just basically said, Ali, sorry, whatever you say is just not worth listening to. I'm going to chat about something else. Sorry, Ali. Carry on.
You cross multiply it.
Okay.
So then you have.
So by cross multiplying, you basically end up with the 12 up there and the 7 up there.
Yes.
Yeah.
And then
So
it's less confusing for me than finding.
But do you understand the difference is what you're doing is actually what we've done,
Yeah.
but with less understanding of why you're allowed to do it.
Yeah.
That's all. You're doing it because you know you're allowed to put the numbers up there rather than realise. So I have, yes, if I multiply this side by 12, I get 12, and then, but what you do is you miss 2 steps. You miss that understanding of what happens to the denominator and things like that. So carry on, if that makes more sense to you, but I would like you to try and think, well, why am I allowed to cross multiply in that way?
Okay.
So this one is the same thing now, but the algebra is on the bottom. So we end up in this case with, what's the common denominator? We would have x plus 3 times 3x minus 5, rubbish 5, and x plus 3, 3x minus 5. But on top would be 4 lots of 3x minus 5, and this would be 5 lots of x plus 3. Now, can you see what I was just talking about with Ali, how although this is the whole thing, it looks super complicated, but if you actually then say, well, the denominators don't matter because they're the same, can you see how it looks like we've just taken this and stuck it up there, and we've taken that and stuck it up there? That's your cross multiplying. But what you're actually doing is making the same denominators. Yeah? Does that make sense? Okay. Yeah. So now we expand. 12x minus 20, 5x plus 15. Add the 20, so 12x is 5x plus 35. Take away the 5x, so I've got 7x is 35. Divide by 7, I get x equals 5. Yeah? You getting it? Let's tell you what you're asking about. Right. What do we do with this one then?
I can do it.
Okay.
So what I did is I put the 1 underneath the 2, like as a denominator.
Yeah.
So I can think of it as both fractions. And then I like cross multiplied them.
So same thing really applies. I'm going to make the same denominator again. So I've got 6n minus 4 over 5n minus 4. The common denominator could be 5n minus 4. So that would make on this side 2 times 5n minus 4 because we multiply top and bottom by the same. Make sense?
Yeah.
Again, if I were to then forget that, what does it look like? It looks like I've taken this and put it up there. That's why moving things gets used. Yeah.
So when we're doing answering questions like this in certain conditions, are we gonna
For a test, all right.
Yeah. Should we use your method, or like is it okay to use cross multiply?
The only reason I'm giving you what I'm giving you is hopefully to improve your understanding. If you are blocked to everything I've said because I know how to do cross multiplication, fine. Do what you like, as long as you get the right answer. The only reason I'm telling you, hoping for you to understand, is because when you get to IB and you're hopefully doing HR maths, suddenly moving things and just remembering cross multiplication doesn't cut it anymore. You have to have a deeper understanding. And ideally, we want as many people as we can to go on and take HR maths, right? Yeah? HR maths is seen as this, it is very, very difficult, but it's only difficult if you don't understand the maths. As soon as you focus more on understanding than tips and tricks, it becomes easier. Believe me. Alright? Because you're used to just being told this is how it's done, Ali. Having a little giggle rather than listen. I know what your focus is. Because you're used to just using these tips and tricks, that's when things get harder. If you learn the understanding, actually nothing changes. You just apply the same things to different situations. Alright? So this is what's happening. we can forget the denominator because it's not that it's not there, it just doesn't need to be considered. So we've got 6n minus 4 is 2 lots of 5n minus 4. Looks like cross multiplication, but then we've got 6n minus 4 is 10n minus 4. Come on, I've given you long enough to shout out and say it's wrong.
Wrong.
What's wrong?
I don't know.
What? Should be
-8.
-8. Thank you. Right, that should be -8.
Top a little. Shouldn't it be 5n plus 4 on the other side, or is that only when they're in one fraction?
Again, that's when we want to rationalise the denominator.
Okay.
Yeah?
With this,
So what you're talking about is when you have root 2 plus 3 and you want to multiply it by root 2 minus 3 to rationalise the denominator.
okay.
You don't need to do that unless we've got surds.
Okay.
We finish off with, take the 6n, that makes 4n, add the 8, that makes 4, so n equals 1. Alright?
For some reason, I thought, like, since like I got something different, but you did 4 over 4, and I thought it was 0 instead of 1.
Yeah, it's one of those things when you look at pictures rather than understand what's going on there. Yeah. Yes, Evan.
Okay, so let's just say we're in a test, right? And you do a question, but you get the answer right, but your method is wrong. Would you get your method
It
right?
depends. So quite often with questions like this, I would, with your IGCSE, I just look at your answer, and if your answer is correct, you get full marks.
Because
However, there are certain questions, this is where they get more into it, where they say, show that the answer is. Then you have to show complete work. That's where I can see the change in exam papers. There are now more and more and more show that this is the answer questions. Because it's actually relatively hard to write a question that you can't accidentally get right. Because there are so many times where if you do one thing wrong and then you do the next thing wrong and they're common mistakes, the two wrongs cancel each other out. So your answer would be right. Now, what do you think? Should you be allowed that mark?
Yeah.
See, I would say no, because you've got there accidentally. Your answer is, how you got to your answer is wrong. So a test should test understanding, not a list of correct answers. Okay? But you're lucky in that most of the time the correct answer would get you full mark. Okay. This one, same thing applies, doesn't it? Common same denominator. So what's the denominator going to be? 20. What do we do with the 2?
Oh, I put it as 40.
Yeah. I'm going to make that 40 over 20. I'm not going to ignore it. Every single part of it. So this bit has to be 4 lots of x plus 3. This bit has to be 5 lots of 2x plus 1. Now I've got that, they're all the same. I can ignore they exist. So I'm going to have 12x plus 3. I am going to stick it back in brackets. I don't need the first one in brackets, but the second one I do, because I need to subtract all of 10x plus 5. Okay?
Is it 40?
Yeah, sorry. So now we're going to do, I'm going to collect like terms, so it's 12x subtract 10x, which is,
Mr. Fox,
yeah,
why is it 12x?
sorry, yeah. I don't know why, I was thinking 4 times 3. I've done it the wrong way around, haven't I? That should be 4x and 12. See, mistakes happen when you're talking. So this should be 4x minus 10x, and then we've got plus 12 minus plus 5, which is minus 5. So if I just wrote this without brackets, it looks like I'm actually adding 5, and that's the common mistake. That's the mistake the 2 girls that handed their assignment in made. And I'm sure the majority of you in here will make that mistake. Okay, so it should be minus 5. So that's why when we subtract, keep that second one in brackets until you're finished. So then we've got minus 6x and we've got plus 7. And then we've got minus 6x equals, so take away the 7 is 33. So then I've got x is 33 over 6, which if I...
-6.
Yeah, negative 6. Again, that's a common mistake that happens. People, the negative goes missing. Simplify that to divide it by 3 gives me 11 over negative 2, which is then easier to put as a decimal, which is negative 5.5 if you want as a decimal. Yes, Josh.
I'm confused where the 40 over 20 comes from. Oh, I understand the 20, but I don't understand.
Because the question is equal to 2, but I want it all as the same denominator. So what divided by 20 gives me 2?
Oh, okay.
40. Yes, ma'am.
For this question, that one.
Yes.
Wouldn't it
Which
be,
one? This one that we're working on?
No, that one.
This one.
Wouldn't it be -1? Because to cancel out 4, you have to add 4 on each side, so that it will be -4.
Yeah. Yeah. But then I subtract 10n, and then I'm left with, if I do it your way round, I get left with negative 4n equals negative 4, which makes n equals 1. What I did was add the 8 instead of add the 4. So I think what you did was look at the 6 and the 10n and just decide that was positive 4n, rather than actually continuing with the add or subtract. Alright? So those 4, they're about the limit that we need to be able to cope with. Are you happy enough? Those that struggled, have you sorted out where your problems lay? Okay. Right. What we want to work on today, okay, we are going to do the distance between 2 points. Okay, I asked you to have a bit of a read on it. Anyone manage that? Nope. So let me just ask you one thing. I've got point A is at 3, 5 and point B is at 2, 6. I want the equation of that line, please, that joins those 2 points first. Just as a bit of a recap. What's the equation of that line? Okay, so if I want the equation of the line, first step gradient, how did you do it?
I subtracted 5 from 6 and 3 from 2.
So you did 6 minus 5, which is 1, and then
2 minus 3.
2 minus 3, which is
Negative 1.
-1. So your gradient is?
-1. Well, 1 over -1.
Okay, so 1 over -1, that happens to be -1. Okay. I saw Sophia down front, fine. Sometimes I do this as well. I'm just going to picture it for myself. So if B is at 2, 6, I'm going to put a dot roughly there. So that's roughly 2 and 6. And I know A is going to be at 3 and 5. I don't need to be particularly accurate about this. I'm just kind of visualizing it. So then I can see that my run, so the run is 1 and the rise is -1. So there's my rise over run again. Okay. So in fact, have I got this the wrong way around? Does it matter? No, but not in this case. I think actually, because I did the subtraction one, if I'd have done 5 minus 6 and 3 minus 2, I'd have got it the other way round and got the same answer. But so what Madison did, it doesn't matter which way round you do the subtraction as long as you do it the same way for both numbers. Okay? Me, again, because I'm quite a visual person, I actually think I'm going 3 to 2, which is -1, and then 5 to 6 is +1. So that's how I do my rise over run. Or if you have a picture in front of you. How do we find the y-intercept? So we've got y equals gradient -1, that makes -x, okay, plus something. Now, having just marked someone's work, what they did to work out the plus c was use these two numbers. What's wrong with that?
That's not a coordinate.
So we need to use a pair of coordinates. So I don't want to use 5 and 6, I want to use 3 and 5, or 2 and 6. So in this case I'm going to use 3 and 5 and go 5 equals -3 plus what?
8.
8. Okay, so we've got y equals -x plus 8, written neatly in a nice elegant way that we like to do in maths. We would write 8 minus x. Okay. How far apart are those 2 points?
Which ones?
Two completely different points than I've given you already. Those ones.
They're
How far apart? What's the distance between those 2 points?
7.
How'd you say so?
Because 8 minus 1 is 7.
So you've just taken numbers from the equation and that'll do, type of thing?
No, but
Is there reasoning behind that?
if you have -1 and 8, the distance between them is not. It's not. The distance between them would be.
-1 and 8 would be 9, not 7. Yeah. But why am I taking? Are you taking this -1 and this 8 and working out the distance between those two numbers?
Yeah.
Well, why would that give you the distance between the 2 points?
Aren't those the 2 points?
No, the 2 points are 3, 5 and 2, 6. Haley?
Is it like square root 1 squared plus square root -1 squared?
Why? What are we doing?
Find the hypotenuse.
Okay. Alright. This all links in. What I'm actually looking for, I am looking for this distance here going between those 2 points. That's what I'm looking for. So what we do is we use something that you already know about, and we also link it to the rise and run that you're already found. So I know that my rise is -1, but in this case it doesn't matter if it's positive or negative, and my run is positive 1. So what have I drawn by doing rise over run right next to the line?
A triangle.
Triangle. What type of triangle? I've got a right angled triangle. And what can we use to find the length of one of the sides? Pythagoras' theorem. Okay? So, to find the distance between those 2 points, I use my rise over run. Now, I don't think they're going to tell you it like that in the textbook, that it is rise over run. But if you've had to work out the equation of the line, you've already done rise over run. And you probably will have to do these things. But that's basically it. So we now have a triangle, excuse my wonky lines now, that goes from 5 to 6, so it has a one side length 1, and it goes from 2 to 3, so it has a length of 1. It is a right angle triangle, so we are doing...
A squared plus b squared equals c squared.
So this one's nice, isn't it? So it's 1 squared plus 1 squared equals
1.
c squared.
How come it's 1 squared? Why isn't it just a plus b plus c?
Oh, okay. Right, that's a perfectly valid question. Is a squared plus b squared equal to c squared? Is it the same thing as a plus b is c?
In this case, no.
In any case.
No.
Try it, Jen. 2 squared plus 3 squared, I know equals 5 squared because it's a famous Pythagorean triple. 2 squared is 4, 3 squared is 9. No, it's not that, is it? It's 3, 4, 5. Sorry.
Yeah.
3 squared is 9. 4 squared is 16. 5 squared is 25. They add up. What about 3, 4? Make 5.
No.
No. Doesn't work. Just in the same way, Jen, that a plus b squared is not, which I saw someone do in their assignment as well, a squared plus b squared. They're not the same thing, are they?
They're A plus
It's a plus b and a plus b, which turns into a squared plus 2ab plus b squared.
Oh.
Yeah? You may remember it as 2x plus 3 squared is not 4x squared plus 9.
Oh, well, I did that.
Yeah. Okay, it is not that, is it? We've discussed that. So anyway, what is the length of this line?
2.
No.
1.
What? 1
times 1 equals
1 plus 1 equals 2. So c squared is 2. Therefore,
So 2.
c...
That always confuses
1
me.
squared.
What?
Wait.
That always confuses me.
What confuses you? Ali, you're going to have a bit of a fit at some point going, why don't I understand anything? And I'm just going to point you back to this time. Stay focused. What don't you get, Jasmine?
Okay. So you do a square plus b square, and then it equals c squared. But then
You square root it, you don't square it.
So what I'm saying is, if I do 1 squared and I add 1 squared, the result is c squared. It just so happens in this case that 1 squared is 1 plus 1 is 2, but that is equal to c squared, not c. So to find c, I have to do the square root of it. So let's do another example. We might make better numbers, because this was one from the book. Let's do another example. So let's find, this time, just the distance between the 2 points. Okay? Let's find the distance between 2 points. I can put the notes back up in a minute if you like. We've got point P is at 2, 4, and point Q is at minus 3, 2. This is in your textbook, by the way, if you wanted to open and see it. Okay, should we go? Do you want to do it now, or do you want me to go through it with you? I'll just go through it. Okay, so again, what we have to do, I like to visualize it just a bit. Here's my axes. Point P is at 2, 4. I'm going to put it there. Point Q is at minus 3, 2. So I've got minus 3, 2. That's at 2. That's at 4. Are you happy with that? Mm-hmm. Yeah? So my line looks like this. Now, you'll get to the stage where you don't need to do that, because there's a formula in the book for those of you that like your formulas, but this is me. This is my take on it. I like to be visual and logical and step by step and so on. So what do? I need to work out Pythagoras' theorem, so I need rise over run. Okay? So I'm going to draw my triangle. The rise is from 2 to 4, which is 2. The run is from minus 3 to 2, which is 5. And also, that stops me making the mistakes of doing minus 3 to 2 is 1. Because that will happen as well. Because I can quite clearly see it's quite a long one. So, Pythagoras theorem, to find this length, okay, we would do a squared plus b squared is c squared, this being c. So, what is it? 5 squared plus 2 squared should equal c squared. So 25 plus 4 equals c squared. So 29 is c squared. Could someone correct Hayley's use of language, please? C is root 29. Thank you. Is there any way of simplifying that third? Anaya?
I have a question.
Okay.
So the distance is root 29.
Yes. That distance is root 29. What is root 29 if you like as a decimal? Do it on your calculator. Square root of 29. What'd you get? It's going to be 5 point something, isn't it?
516.
5.38516. Okay?
It's a prime.
Goes on forever, no? Keeps going. So if I want a rounded length, I would do 5.39. If I want the exact answer, leave it in third form. Do you remember that? Okay. Feel a bit better about those numbers. Make more sense, yeah? So that's it. What about the equation of this line? Let's do it quickly, just practice. Equation of this line. Y equals, what's the gradient?
2 over 5.
2 over 5, great, it's already there. 2 over 5x plus something. What coordinate could I use? 2 and 4, okay, so I would write 4 equals 2 over 5 times 2 plus something. This is a nice practice one. So 4 equals 4 over 5 plus something.
C equals 16 over 5, right?
How'd you do that?
Because 20 over 5 equals
Because 4 is 20 divided by 5. And I have 4 over 5, so I need to add 16 over 5. Well done.
Jasmine, you're so smart.
Y equals 2 over 5x plus 16 over 5.
Same Jasmine girls.
Well done. Alright. Do we need to scroll up or anything? So, I tell you what, turn to page 261. Page 261, we've got exercise 12b.2. You can have a look at doing some of those questions. It's the distance between 2 points. There are a few examples there on the previous page of how it gets harder. So for those of you that want to go straight to some hard stuff, review the examples. Have a look at questions 1, 2, 3 and 4 and pick your point. Pick an easy one. If it's too easy, move on. If it's not too easy, stick with it. Any questions on that? What are you doing? No?